without doubt, the daftest thing people ever did was name their planet Earth. Why? Because the commonest substance on the face of the Earth is this stuff, water. And thank goodness it is, because about 65% of every living thing, and that includes you and me, is made of this very versatile liquid. So it's little wonder that the sea abounds with life, from the smallest floating plants and animals to the largest mammal that has ever lived. This is Earth's own inner space, a wraparound reservoir complete with mega and mini monsters, as strange as any from the pages of science fiction. But these are all science fact, and so are the strange properties of water which makes all things possible. Each water molecule consists of 2 atoms of hydrogen and 1 of oxygen, all of which bear tiny electrical charges, oxygen negative, hydrogen positive. So they behave like little magnets. They continually attract each other, and the electrical charges give them a great capacity for engulfing other chemicals. Yes, water is good at dissolving things, and if it wasn't, there'd be no salt in the sea and no life at all. No jellies, no fish, and no us to wonder and worry about the past and the future of our watery world. Over much of the surface of the Earth, the temperature ranges are such that water remains as a liquid. Not too hot, not too cold, but just right for all those live processes. But in places where the temperature falls, then sea ice begins to form. And there you are, a baby iceberg, all of my own, and it floats. At 4 degrees centigrade, all the little molecular magnets are packed tightly together. As liquid water starts to turn into solid ice, crystals start to form, and the water molecules are pushed further apart. So solid ice is less dense than liquid water. That's why it floats on the surface, where it provides a home base for animals like the walrus, riding high on the ice pack, reflecting on the denser, warmer water down below. Sea ice also acts as a giant white mirror, reflecting the energy of the sun, helping to keep the planet cool. If ice was denser than water, it would sink down into the depths of the ocean. The oceans would then fill with ice, and life as we know it would become impossible. Life on the ocean wave, at home in the briny sea, idyllic. But what about us landlubbers? We need water without too much salt. Never fear, thanks to the unique properties of the stuff, I am floating on top of a gigantic solar-powered desalination plant. At the surface of the sea, water molecules continually break loose from their magnetic bonds, turning into an invisible gas called water vapour. The salt is left behind and the sea cools down, just like you and I when we sweat. Every day the Earth sweats, and as it does, 1,145 cubic kilometres. Think about it. 1,145 cubic kilometres of seawater are purified by evaporation and escape into the atmosphere. So the water cycle is both a heat pump, a water purifier, and a worldwide sprinkler system which dumps 300 million litres of water on the dry land every day. Unfortunately, most of it either evaporates or runs quickly down into the sea. We and all the rest of the life on the land have to grab our share as it flows past. I'm surrounded by one of the most efficient water-driven power plants in the world. Its name is Isonia crassipes, or the water hyacinth. Now, as water is one of the main raw materials of the process of photosynthesis, which allows plants to fix the energy of the sun and make more of themselves, this plant, Isonia, is perfectly adapted to take up all the resources available. First of all, we have its solar panels, these strange-shaped green leaves, and even the fat bulbous leaf stalk, which makes it such a floaty plant, is covered with chlorophyll green, and then underneath, great masses of roots dangling down to take up all the nutrients there in the water. And the whole of that, well, 90% of it is made of water itself. And that goes for even the baby offshoot plants that are budding off all the time. So, given the right temperature, this plant can take over the resources of this pool in just a matter of a few weeks. Now, it may be easy to understand how a tiny little plant going way down there beside the pond gets all the water it needs up into its leaves. But how about the palms and trees and things? I mean, how does the water ever get up to the top of those? Well, an experiment. This is a state-of-the-art late 20th century capillary tube. And the capillary tube is a fine glass tube with a tiny little hole all the way down the middle. Now, if we add water at the bottom, something magical should happen. I'll keep my fingers crossed. So you can see it, we've coloured the water. Yep, here it comes. 9. Now, that's not bad, just over 9 metres. I must confess we had to cheat a bit to get it up there. But physics tells us that if we had the perfect capillary tube and the perfect system, then the water all by itself would rise up to about 9.7 metres, 32 feet. No pumps, no suction, all thanks to the very special characteristics and properties of this rather strange liquid called water. And the secret lies in the meniscus and surface tension. At the surface, the water molecules are densely packed in the form of a tough skin. Where the skin touches the walls of the tube, it creeps upwards. And that's what happens inside plants, because they contain millions and millions of tiny capillary tubes. That's what tree trunks, and come to that, most vegetation is mainly made of. The finest of fine capillary tubes. Evolution's answer to taking over the surface of dry land. So as long as the roots are well supplied with water, it will rise up to 9.7 metres all by itself. But what about the rest? Trees can grow to 10 times that height. Here I am, almost at the top of a tree in high-rise rainforest. I'm completely surrounded by millions and millions of highly sophisticated solar panels, each one of which must be kept supplied with that precious liquid. Because without water, the leaves can either trap the energy of the sun, and without water, they'll get too hot and die. They're solar-powered and water-cooled. And thereby hangs the explanation of how water gets to the top of the tallest tree. Remember, all those capillary tubes are packed full of molecular-sized magnets, which form continuous chains down into the soil. So, as water is lost by evaporation at the top, they all move up one to take its place. It's as simple as that. The only thing that's going to stop them is when the chains of demand and supply are all broken. tropical rainforest is a self-built, self-repairing reservoir made almost entirely of wood, and it stores a vast amount of water. And this plant I'm sitting on proves it. It's the water vine, and I borrowed a bit from one over there on the trail, and I'll now demonstrate a drink of pure water, a gift of the forest. And that's just part of a fantastic 1,350 tonnes of the stuff held on every hectare of this landscape. And as every hectare evaporates about 60 tonnes of water a day to keep it growing, it also acts as a giant air cooler, sending a plume of cool air saturated with water vapour back up into the atmosphere. When this falls as rain downwind, it pumps the heat back into the clouds, so helping to keep the local, regional and global climate well watered and in balance. And all that's required to keep the rainforest growing and doing all these important things is an equable temperature and more than 2,000 millimetres of rain evenly spaced throughout the year. But that means that more than 20,000 tonnes of water fall every year on each hectare of land, enough to service the needs of more than half the plants and animals of the world. Rainforest is destroyed for many reasons, some by very rich people for profit, some by very poor people in desperation. But the end result is always the same. People, plants and animals are dispossessed of their land, and the chance of catastrophic floods increases, carrying away the soil, causing havoc further downstream and helping to change the climate, local, regional and some believe even global. As the rainforests are destroyed, at the other end of the watery scale, semi-deserts are expanding across the earth. Here, in a good year, 10,000 tonnes of rain waters 2 hectares of land. Unfortunately, the supply is very erratic, so the vegetation is as sparse as the life it supports. The spring rains have been and soaked away into the soil out of reach of the animals, but not out of reach of the roots of the plants. And although there hasn't been much so far, it's enough to allow a new crop of leaves, food for the animals, but also, just you look, a source of water. And although it's pretty salty, if that's all the water you got, you have to put up with it. And of course, that's all the water the animals have got round here, because the only thing drawing water up to grazing level are the few scruffy plants which manage to survive. But I must say, by the look of the clouds, perhaps there's more rain on the way, so it could be a good year for the nomads and their flocks. As long as the nomads get the balance right, their families and their flocks can thrive. 10,000 tonnes of water can support 100 nomads and all their animals for 3 long years. Living in such an environment has never been easy, but in a good year there are many rewards. Sustainable life set in the midst of a beautiful environment. So beautiful that tourists now come in their thousands to soak up the sun and the local colour, and they too must be supplied with water. Swimming pools and fountains aren't so bad, for apart from evaporation, this water can be used again and again. But just think of all the meals these people will want to eat. The plates and linen that's going to have to be washed, and the baths and showers they're going to take. Floors and paths to be hosed down and scrubbed, let alone water in the pleasure gardens. Now, thousands of such hotels dotted around the semi-desert world are causing real problems. It makes you think that 10,000 tonnes of water that used to keep 100 nomads and all their flocks going for 3 years only keeps 100 package holidayers supplied for about 5 weeks. That means if this one hotel was full of guests, there's 3.5 days' supply. And of course, the actual supply of water isn't getting any greater. In fact, here in North Africa, it's getting less because the climate has been getting drier for the last about 10,000 years. This all used to be covered with savanna, trees and grasslands which supported large herds of wild animals, and later people who learnt how to farm the land. By around 1200 years ago, much of the vegetation had been destroyed, and with it the water holding capacity of the system. So the locals began to build chains of wells called foggera, leading back to tap supplies of available water back in the mountains. It was an enormous feat of civil engineering, for each well is connected to the next, piping the water, in some cases for 50 kilometres, to where it could be used. Some are still maintained in working order, but it's hard and dangerous work because there's someone down below digging up the mud. So most of them are now disused, their vital work replaced by less civil forms of engineering. Diesel pumps tap deep supplies of groundwater much faster than they can ever be replaced. And at this rate, it's not going to be very long. Immensely expensive dams of every shape and size hold back the water to be used lower down the valleys. Problems all the way. Silt builds up behind the dam and water evaporates from the open channels, concentrating the salt in the water, most of which will be used for irrigation. There are short-term gains for some, but the whole water, salt and nutrient balance of the landscape changes, and always for the worse. Snow on the mountains and the promise of irrigation water later in the season. And down it will come and be used to irrigate these dry plains to grow some crops. But the balance must be got right, you see, because the sun's going to evaporate that water and leave the salt behind. Yes, this isn't a sprinkling of snow, but it's salt actually coming up from the soil as evaporation takes place, making it impossible for any crops to be grown. And to prove it, Juncus maritimus, the sea rush, usually found growing with its roots in salty water. Factors like these are rarely taken into account as nations pursue the proud boast that not a drop of water will reach the sea before it's been used again and again. So, wherever we look in the world, we find that much of the vegetation has already been replaced by crops, and they all demand water. Deciduous woodland in the springtime makes me feel quite at home. But remember, most of our woodland has long since been replaced by agriculture. Now, hereabouts, the farmers have been slightly more crafty. Yes, most of the original trees are gone, replaced by crop trees, figs and apricots, almonds and peaches. And here's the real crafty bit. While the leaves are off the trees in spring, they flood in the irrigation water and raise a whole series of ground crops, barley, wheat, chickpeas and beans. But you see, that means they're using more water than originally was supplied to the woodland hereabouts. And of course there's always a temptation to remove all the trees and go over to intensive irrigated agriculture. And that is exactly what is happening. More and more of Earth's diverse ecosystems are being replaced by water-guzzling agriculture, more often than not with catastrophic results, for the statistics of water use makes horrendous reading. Tropical forests once covered these hillsides, now terrace for rice. It takes 4,700 tonnes of water to produce 1 tonne of rice. Summer dry forests in Africa now producing cotton and jobs for the locals, but it takes 17,000 tonnes of water to produce 1 tonne of cotton. This was once natural grassland, each hectare of which received 5,000 tonnes of rain a year. It takes 12,000 tonnes of water to keep a hectare of grain growing. All over the world we're using water as if there was no tomorrow, and it's not just in the poor developing world. The Alps, heartland of the European community and a crucial part of the economy of many very rich nations. These mountains are the water towers of Europe, for the rain and especially the snow which falls on their mighty flanks keep the rivers flowing and farming, commerce and industry supplied with water throughout the dry summer. I'm standing on top of a very important part of that water tower, one of the giant glaciers of the Alps. In fact, an enormous pile of frozen fossil water. And I tell you, it is good, and it does the European economy a lot of good too, because every winter more snow and ice forms up here, and then in the spring and summer it slowly melts, trickling away and keeping all those European rivers topped up with the water we all need. But all is not well. Possible climatic change, the drainage of alpine meadows, the impact of skiing and tourism, acid rain and photochemical smog killing the trees all increase the likelihood of avalanche and decrease the capacity of the mountains to hold the water on their slopes. It costs an awful lot of money to build dams to perform those same vital functions. We in the affluent West demand more and more water all the time. In the not too far distant future, it could be 1,000 tonnes per head per annum. What is more, we produce all sorts of toxic chemicals on purpose and as byproducts of our lifestyle. Accidents do happen, and some of these chemicals end up in the water supply. Following a fire at this factory on the Rhine in 1986, a cocktail of dangerous pesticides drained into the river. Billions of gallons of water were polluted, and all the life in the river was destroyed for 100 miles downstream. Everywhere we look, there are problems of water and water supply, and Venice is a city with much more than its fair share. Built on wooden piles and stone piers sunk deep into the mud, it has struggled to keep its head above high water mark for the past 1,200 years. And in the past 50 years, in an effort to keep abreast with modern development and cater for the needs of 2.3 million tourists a year, the problems have become acute. Beautiful, isn't it? Just one of 300 wells which used to supply Venice with all the fresh water it needed. But then, as the population built up, they had to sink deep shaft down and pump the water up. And so the salt water flooded in, contaminating these surface wells. And so they're all sadly now capped over, part of Venice's magnificent past. Wrapped around this major tourist centre is an enormous industrial zone, and to keep that and the visitors supplied, more and more fresh water was pumped from underneath the city, with the result that Venice began to sink. The problem was only stopped by drastic and expensive action. And now there's a new problem on the horizon. They've gone and discovered oil out there under the Adriatic. 2 rigs at the moment and 18 coming online. And of course, as they gush into production, the oil comes up, Venice will start to sink again. And in part, burning that oil, causing the greenhouse effect, could make the sea level itself come up. And this is just the result of an onshore wind, a moderately high tide and a bit of rain. Venice, really does have its own watering problem. Not the least being the fact that Venice has no sewage system. Each building has its own septic tank, the overflow from which spills out to mingle with the rising tide. But for these walkways, the tourists and Venetians alike would have to paddle in their own diluted bath water or worse. But they're lucky they can always get their drinks in cans. Water, water everywhere, and less of it is fit to drink. Every year, at least 30,000 people die of waterborne diseases like cholera and bilharzia just because they had no access to pure water supplies. At the other end of the scale, mismanagement of catchment puts too much water in the wrong place at the wrong time, and floods are killing more and more people. Deserts are expanding, and by the end of this century, 1/3 of all the world's agricultural land will be stricken by drought. But the most sobering thought is that 1/3 of all the world's main river basins are shared by 3 or more nations. Or are they? Water wars may well be the next thing to engulf the world unless we put our waterworks in order. The only good news about the water cycle is every day an incredible 1,145,000 million tonnes of the stuff evaporates from the surface of the sea, leaving most of the pollution and the salt behind. So it gives us another chance. And a quarter of that pure sweet water flows down onto the land. And that's all we've got, our total world supply, thanks to the strange properties of this stuff and the heat, the energy of the sun.
David Bellamy explores the essential element nitrogen next week.
As it looks at the